Okay, how to solve systems of linear equations is our goal now. First, we're going to use elimination to try to solve them. So in your textbook, go to example 2, and you'll see an example of a system of nonlinear equations. And watch how your textbook author solves this. So this is on page 670. Go ahead and watch that video. Pause my video, watch that, and then come back here and we'll try one together. Okay, so in your homework from 1 through 12, you're doing 1 through 8 and 11. So we're going to do number 2 together. That's from your homework. And 6. So starting with number 2, actually from that video you just watched, go ahead and try number 2 or number 6 on your own. And then come back here and we'll fill in the gaps and do this together. Okay, so for number 2, we're using elimination. So I'm going to name these equations so I can manipulate and add and subtract. Remember, with elimination, we can add or subtract any multiple of one equation to the other. So I'm going to try to get these y's to cancel out because that's the only like term I have between equations, right? X squared and x are not like terms, so I couldn't add those. But if I add y and y, I can get those, well, if I subtract y from y, then I can get them to cancel out. So I'm going to take equation 1 and subtract equation 2. So what 1 is x squared plus y equals 2. And negative equation 2 is negative 2x minus y equals positive 1. So when I combine those, I get the y's to cancel out, and I get x squared minus 2x. So now I have a quadratic equation that I know how to solve. So I have x squared. I know that with quadratics, I have to set it equal to 0. So I'm going to add 3 to both sides to get that equal to 0. And then I can factor this to get x equals 3 or x equals negative 1. So I have two possibilities. So I have x equal to 3. If x equals 3, then what's y? I can pick either equation and solve for y. And plugging in the 3 for x, we get x squared is 9 plus y equals 2. So y, subtracting 9 from both sides, gives me negative 7. So that gives me the solution 3, negative 7. And I also said that x might equal negative 1. And if that's the case, then to solve for y, I use an equation from the original system, and I plug in negative 1 squared is 1 plus y equals 2. So y equals 2 minus 1, which is 1. Which gives me the solution negative 1, 1. So I have two ordered pairs in my solution, and I want to check both of those. So I could check it by graphing, or I could check it by plugging it into those original equations. So to check that, so I'm going to check 3, negative 7 first. So checking that into, I'm just going to make a note, these are my solutions. And I'm going to check the 3, negative 7. So to check that, in equation 1 was x squared plus y equals 2. So when I plug in x, I get 3 squared, and plug in y, I get minus 7. That's 9 minus 7, which is 2. Check. And my second equation was 2x plus y equals -1. Whoops, sorry, we don't know if it equals -1 yet. We want it to. So the 2x, x is 3. And y is -7. So I get 6 minus 7, which equals -1. So those equations check. And that solution is good, check. And my other solution to check is the -1, 1. So plugging that into the first equation, I get x squared plus y equals a -1 squared plus 1, which equals 1 plus 1, which is 2. So that's correct. And equation 2 was 2x plus y, which is 2 times -1 plus 1, which equals -2 plus 1, which equals -1. Also check. So that's how I check those, and now I say that both those solutions are valid for number 6. So that one has 2 solutions. So remember, with a parabola and a line are different options. One of those options was to have 2 solutions. All right, let's try number 6 now. Now that you've seen 2 examples, go ahead and pause the video again and try number 6 on your own. All right, so number 6, let's do this one together. So again, I'm going to start the same way by naming these equations so I can manipulate them. I want to get the y's to cancel. I again have a parabola and a line. So I have to get the y's to cancel because the x's are not like terms. I can just add equation 1 to equation 2 and my y's will cancel. And I get x squared minus y equals -7 for 1. And equation 2 is x plus y equals -2. So I get x squared plus x, my y's cancel, and I get -9. Okay, so to solve a quadratic, I have to set that equal to 0. So I add 9 to both sides. And then to solve this quadratic, this one doesn't factor. There's no 2 numbers that will multiply to 9 and add to 1. So I have to try the quadratic formula. So it does not factor. So using the quadratic formula, I get -1 plus or minus the square root of 1 minus 4 times 9 all over 2a. And I see that I'm going to have a negative under the square root. So that's x equals 1 plus or minus the square root of 36. 1 minus 36, that's a -35. That's not real. So these, there's no, that must be shaped something like this where those don't touch. So there's no solution to this one. So if you get a number that's not real, looking at a system, then there is no intersection, no solution.